Space and Rocket Review. What's going on, everybody? Welcome to the EJ Space and Rocket Review. I am EJ, your host. It is July 14th, 2026, and this is an earlier space news for the day. We got, there's some interesting NASA papers that I want to look over, and then in about an hour into this VOD, we'll pick up the coverage for the Soyuz MS-29 docking. So yeah, the space is going to be a little bit earlier today, but yeah, here we are. Let's jump in. So the paper that I wanted to go over is right here. Chat just told me about it a second ago on the Twitch side of things. Here, check this out. That is what we're looking into. So NASA, a little bit of a primer here. NASA has looked, well, actually it says right there. The NASA Space Launch System is evolving from the Block 1 ICPS upper stage configuration to incorporate a new, more powerful Centaur upper stage, Centaur 5 upper stage. The larger Centaur 5 provides greater performance, unlocking possibilities for future missions, including sustained lunar missions, large cargo deliveries? Faster transits to the outer planets, and more. Using flight-proven elements, the uprated SLS will provide a stepping-stone architecture to the moon, Mars, and beyond. So yeah, so NASA's Space Launch System, guys, has a little bit of an issue. The issue is that you don't really have a good upper stage for it. The upper stage that it uses right now is called an ICPS. It's the Interim Cryogenic Propulsion Stage. And I'm sure the paper will tell you about it, but I'll just give a primer before we read the paper. So, right here, give me one moment. Right here is a shot of an ICPS. It is a separated tank design. So you have your hydrogen tank up here and your liquid oxygen tank down here with your what's called an aft deck, and then your engine integrated into the aft deck right there. Now, why do this design? Well, the reason why they did this with the ICPS is how the ICPS actually works is that the LOX tank and the engine is actually hanging. It's hanging inside of an interstage adapter called the Launch Vehicle Stage Adapter here on SLS, right? Or the interstage on Delta IV. And this way, the hydrogen tank only has to bear the full load of the first stage pushing up on it. This way, having your LOX tank hanging and having your engine hanging means that they're not in your primary load path. Having them hang there makes it so they don't need to be as structurally strong to withstand the whole stack of the vehicle. Now, the ICPS is derived from a Delta IV upper stage. It's derived from the DCSS, is what it's called. If you type in Delta IV, Delta Cryogenic Second Stage, it's derived from that. It's basically a slightly extended version of the DCSS. Which is it's a Delta IV heavy upper stage. Basically, it's the same thing. Only the one on SLS is just slightly longer. Now, here's the thing. The ICPS is pretty good for what SLS is trying to do. The problem is that the ICPS is a Delta IV upper stage, and Delta IV stopped flying a long time ago. The 3 ICPSs that NASA ordered in 2019 were from when the Delta IV production line was still going. That was a long time ago. The thing is that NASA's running out of upper stages for SLS. They're running out. They only have 3 of these things. They've already used 2. So they have 1 ICPS left for either Artemis 3 or Artemis 4. Now, the original plan for SLS was to replace it with a basically a Gigantor-sized version of the ICPS with 4 engines instead of 1, and it was called the Exploration Upper Stage. The short answer on the EUS here is that it was mismanaged. Basically, they kicked the can down the road a couple of times and bought more ICPSs as well to save money because there wasn't funding for the project. So they put the EUS program on life support, and it ended up costing billions of dollars and ended up doing absolutely nothing. Now, the EUS ended up being canceled in February of this year, 2026. Now, the reason why it got canceled is because it was way behind. It was way behind, and it probably wouldn't have been ready until late 2028, maybe early 2029. Now, a lot of folks on the internet kind of contest, when this thing could have been ready. They could have sped up, they could have slowed down, they could have, I would say 2028 at the very least for this, right? And the reason that's pretty spot on, considering they put the program on life support for a long time, right? And then started to decide to do it, right? But NASA's plans have kind of changed since the US was first kind of thought about. The plans is that NASA doesn't really want to go and build a space station around the moon. NASA's just going to focus on building a moon base. And they want to get back to the moon by 2028, which is an ambitious goal. The idea is behind the EUS being canceled is that it probably wasn't going to get done in time. Which once again, it's a very fiercely contested thing with people that like space on the internet when that thing would have been done or wouldn't have been done. I think if NASA put foot to tail, they probably could have gotten it done earlier, but they ended up getting rid of it because it's, at the end of the day, engineering a new upper stage is kind of a pain in the butt. Now, once again, I firmly believe that they probably could have gotten the EUS done quickly, but that's not what NASA ended up doing. What NASA ended up doing was looking to put a Centaur 5 on top of SLS. So it's Centaur V, but V being a Roman numeral, right? They wanted to put Centaur 5 on there. So what is Centaur 5? Centaur 5 is United Launch Alliance's upper stage for their Vulcan Centaur rocket. Centaur 5 is a 5-meter stage with either one or two RL-10 engines in the back. Now, the ICPS has one RL-10. You could do a dual engine Centaur. It's called a DEC for short. Right. It's a little bit bigger than the ICPS, and it offers a little bit more performance. Now, this is a pretty decent idea at face value, right? This is a stage that's still being made. It's more or less a little bit analogous to an ICPS. It is a different architecture, like in terms of mechanics, right? This is using stainless steel balloon tanks, and the ICPS was aluminum tanks. A couple of trade-offs here and there, but I'm sure the paper will talk about them. But the idea is that you have a standardized version of SLS where you wouldn't have to worry about developing an upper stage. The idea is turbo. The idea is that you can get to standardizing SLS and launch it more, not just up until not only having an upper stage ready for 2028, but having basically enough upper stages ready because you're picking a stage from a production line that already exists. The demerits to this is that Centaur is not nearly as powerful as the EUS. It's, long story short, bigger upper stage on top of the rocket gets you further. And Centaur doesn't necessarily do that. It doesn't have as much fuel as the EUS. In rocket terms, right, I'll keep it simple, but in rocket terms, Centaur doesn't have nearly as much delta V as the EUS did. But, I'm sure the paper will talk about this. Bless you. Thank you. Did some math from the data in table 1. All right, you're getting ahead of me. Let's read the paper ourselves before we do that. Right? So, yeah, this paper is about, utilizing Centaur as the upper stage for the standardized version of the Space Launch System. So, the introduction is probably going to say exactly what I just said in much shorter words, but whatever. NASA's Artemis program is building the capabilities for sustained human exploration of the moon as a proving ground for Mars. The Artemis launcher, SLS, will provide the heavy lift capability to launch large payloads to distant destinations. After 2 successful launches, SLS is evolving in capability with the addition of the new higher performance Centaur upper stage. The Centaur 5, which provides twice the thrust and carries almost twice the propellant load of the ICPS, the interim cryogenic propulsion stage, will increase its SLS ability to launch robust, high science value exploration missions. Both SLS and Centaur 5 are flight-proven, man-rated systems. The Centaur 5. Table 1 lists ICPS and Centaur 5 characteristics. Both use high specific impulse liquid oxygen and liquid hydrogen propellants. Total masses are 71,155 and 119,200 pounds for the ICPS and Centaur, respectively. For the uprated SLS, the Block 1 Launch Vehicle Spacecraft Adapter, the LVSA, that connects the core stage to the 5-meter diameter ICPS will be replaced with a new adapter that connects to the 5.4-meter diameter Centaur 5. For the cargo version of SLS, initial flights will use the 5.4-meter diameter, 21.3-meter long Vulcan fairing. Okay. ICPS is on the left, Centaur is on the right. Centaur uses 2 RL-10Cs. The ICPS uses a single RL-10B2, which has a nozzle extension on it that can actually expand. 460, because of the bigger nozzle in the RL-10B2, you have slightly more efficiency there. This is your miles per gallon for the most part, so that's your efficiency. 462 seconds versus 453. The total thrust is about, on the ICPS, is about 100 kilonewtons, and over here it's about 200 kilonewtons, because it's 2 of more or less the same engine. Slightly different diameter. Centaur carries way more propellant. Yeah, it's like I said, it's a slightly, it's more or less the same size, but the Centaur doesn't have that tiny little LOX tank. It's using a common bulkhead with stainless steel, so you get more volume that way. And Lava Eagle, you said that the ICPS with Orion on it has 3 kilometers a second delta V, and this has almost 4, which, yeah, math checks out there. Propellant mass fraction. So propellant mass fraction is the amount of propellant versus the amount of rocket on the vehicle. So if you take how heavy it is with a full tank of gas, right? And then you drain the thing and you weigh how much it is then, right? That's called wet mass and dry mass, right? The proportion of your wet mass to dry mass is called mass fraction. So it's how much of this is fuel and oxidizer and how much of it is rocket. From that correlation, you can get your delta V. You can figure out how far it can go. Would 3.9 kilometers a second allow Orion to get into low lunar? Maybe. Maybe with Centaur 5. Maybe. You'd need to use Orion's service propulsion system to circularize, but it's possible. But that means you would need to coast with Centaur all the way out to the moon. Neither of these engines can hold their propellants for a long period of time. Because they're using liquid oxygen and liquid hydrogen, and they're really, really cold, and you're sitting up in space, vacuum insulated in the sun, any heat that you absorb from the sunlight stays with you, and it's really easy to get the propellants to evaporate. So the propellants have a shelf life. Just, that's an important thing to understand. Check DMs, not SLS, but it has just been posted. Okay. Yeah, we'll talk about that later, Chaz. Thank you. So Lava Eagle, the math you did for the EUS a while back gave something like 5.6 kilometers a second delta V. Centaur 5 background. The Centaur is built around pressure-stabilized stainless steel tanks, proven avionics, and 2 RL-10 engines with long U.S. flight heritage behind them. Centaur 5's flown history begins on January 8th, 2024, when it made its debut on the Vulcan Certification 1 flight. On that first mission, the new 5.4-meter cryogenic stage helped send the Peregrine lunar lander on its translunar injection path. Peregrine ended up failing because of a fuel leak, but it got close to the moon. The Centaur 5 then performed a third burn that sent the remaining payload onward out of Earth orbit. Centaur 5 demonstrated a kind of multi-burn long coast mission profile associated with lunar deep space missions. Boil off? Question? The next major step came on October 4th, 2024, when Vulcan completed the second of 2 certification flights required by the U.S. Space Force. On March 26, 2025, oh yeah, they didn't really talk about Cert 2 too much, huh? On March 26, 2025, the Space Force formally certified Vulcan for national security space missions, noting that the process had covered 52 certification criteria, more than 180 discrete tasks, and 2 flight demonstrations. Okay. Operational use followed. Just for some context here, Cert 2 failed. It did not achieve certification. That's not because of Centaur, though. Centaur performed perfectly. In fact, Centaur saved the mission. Cert 2 failed. It almost blew up. It was very, very close. It's because of nozzle delamination on the GEM-63XL solid rocket boosters that Vulcan has. So if we go back over to this Ars article, Vulcan has attachable solid rocket boosters right there. See that? Yeah, one of those things almost let all the freedom out, like, very quickly. And when solid rocket motors malfunction, you know. Operational use followed. The SF-106 mission, launched on August 12, 2025, also had nozzle delamination failure, and it became the first national security mission to fly on Vulcan. Around the same time, NASA selected the Centaur 5 team to study an extended duration concept for cislunar missions. Then, on Friday, February 12, 2026, the SF-87 mission used a dual-engine Centaur to place a heavy payload directly into geosynchronous orbit, further demonstrating the endurance and precision that made the stage attractive for high-energy civil missions as well. That successful record carries Centaur 5 forward to SLS. Now, I would like to point out that Vulcan has problems with the SRBs, but this paper's right. They're not talking about the SRBs. Centaur 5 has performed perfectly every time, just for what it's worth. In NASA's 2026 Artemis architecture update, the agency said it would standardize the SLS close to its Block 1 configuration, with the Centaur 5 replacing the interim cryogenic propulsion stage after 3 Artemis missions. In separate official planning and procurement documents, NASA then tied Centaur 5 to that path. A March 2026 agency planning summary said the first Centaur 5 mission may be Artemis 4 or Artemis 5. As of April 2026, Centaur 5 has not flown on SLS, but it has clearly moved into NASA's plan. In summary, the history of the Centaur 5 has advanced rapidly. From its maiden flight in 2024, certification and operational service by 2025 through 2026, now Centaur 5 moves into the NASA architecture and is become the upper stage of National Heavy Lift Launcher. Now the Centaur 5 moves into NASA's architecture and is become the upper stage of NASA's yeah, okay. Proofreading? No. No. And is become. Centaur has become death. Destroyer of EUS. Does anybody proofread this stuff? Guess not. Okay, SLS Centaur payload performance. Figure 1 lists SLS's Centaur 5 injected payload versus destination in terms of injection energy, which is C3. That's characteristic energy of the rocket. So that's kilometers squared over Geez, why is my... I hate that my brain just blanked on S. That's really stupid. Apologies. It's characteristic energy. That's what it is. It's basically how far can you go in terms of energy. Yeah, seconds. Why? Dude. Don't worry about it. I knew that. You know I knew that. Brain fart. Okay. Ranging from low Earth orbit, Leo C3 of negative 60.8 to distant Uranus, which is C3 91.5. Preliminary simulation runs indicate that SLS can provide an order of 76.2 metric tons of payload to low Earth orbit. 28.4 metric tons TLI. Translunar injection. So sending it out to the moon, not necessarily stepping on the brakes. And payloads to Mars of 23.5, 22.1, and 20.6 metric ton for... And payloads to Mars of 23, 22, and 26 for easy year C3 equals 9, average year C3 equals 12, and hard year C3 equals 15 opportunities. Basically, what that says in plain English is that Earth and Mars aren't near each other. They only get kind of close to each other every 26 months because Mars is in a higher orbit. So, right, every once in a while they get close, right? And you ideally want to go easy year where your characteristic energy is lower. It doesn't take as much delta V. And your transit time usually is closer, is less time when you're here. Outer planet missions show in Figure 1 include a dual swing-by trajectory of Saturn, which is 16.1 metric tons C329, and 10 and 7-year transfers to Uranus with payloads of 5.9 and 5.1 metric tons respectively, C3 85.8 and 91.5. For Figure 1 data, vehicle acceleration is limited to 2.75 Gs. Because of ongoing analysis, the payload values shown here are notional and subject to change. Crew and cargo versions of the rocket are shown in Figure 2 with a preliminary mass statement in Figure 3. So the reason why you have negative numbers in your injection energy here is... It doesn't exactly mean this, but the core stage can do it. That's the right way to say that. That means the SLS's core stage can shoot this thing. Whoa, wait a minute. Huh. Injection energy is the energy you have after exiting the Earth's sphere of influence. No, I get it, but it's interesting that translunar injection is negative injection energy, which means, am I looking at this right, Lava? The core stage can shoot a fully fueled Centaur and Orion at the moon? Hello? Zero is the energy needed to leave Earth's sphere of influence. Yeah, so if we're talking about if we're talking about injection characteristics here, yeah, translunar injection is in negative injection energy, so that means the core stage can do it. Interesting. That's very interesting. Ah. Dude, I get it. People harp on SLS, but the core stage and the 5 segments are no joke. You can do some pretty insane stuff with them. That tells me that you could easily get a core stage into low Earth orbit for like to outrig as a transfer vehicle. But we won't do that. That's not cool. That's too cool for us to do. We won't do that. Yeah, dude, look at that. So 10C3 for Mars, and you have that's in out of phase transfers, which is crazy. No, those calculations take into account the Centaur too. There's no way that the core has enough delta V for that. Explain negative injection energy for translunar, though. Because lunar is inside of Earth's sphere of influence. Yeah. Okay. Well, what does it say here for 28.4 metric tons translunar injection? C3 is negative because 0 C3 is exact escape velocity. I think this is saying that SLS Centaur can take 30 tons to lunar. Yeah, okay. So if we're talking about injection energy versus relative to Earth's SOI. Okay, I get it. I get it now. No, it's not good. It won't be able to do a direct insertion. You can't shoot Centaur and Orion on TLI in one shot. You'd need Centaur to do it. The moon is inside of Earth's SOI, which is why it gives you a negative C3 number for TLI. All right, I understand. Got it. Standardized SLS. Yeah, you're not going to... That's not... This is what I'm talking about. You're not doing that. That will break a Centaur. You'd need a load-bearing adapter to take Centaur out of the critical load path. They'll talk about that, I guess. Not I guess. I know they will. Notional interstage adapter, 4,000 pounds. All right. Lunar crewed and cargo missions. SLS Centaur will support the Artemis missions beginning with Artemis 5 in 2028 and subsequent missions on a yearly basis. The Artemis 4 mission will begin the cycle of SLS missions that will build the lunar base. Supporting the launch and delivery of surface and orbital assets as well as providing crew missions with Orion, the SLS will also be involved in lunar base resupply once operational. What? Other missions such as launch of a lunar surface nuclear power system are also anticipated. Starting in the early 2030s, the SLS will utilize new lighter weight composite case solid rocket boosters that will increase SLS's payload capability. Also, anticipated will be the optimization of some of the core stage structure, resulting in lighter weight and additional increases in payload capability. An option for the mid-2030s is not in the program. An option for the mid-2030s not in the program of record involves a feasibility study of recoverable engine pod. An option for the mid-2030s not in the program of record involves the feasibility study of a recoverable engine pod. Please do that. Please. Please do that. Please do that. I mean, that's gonna be tough, guys. The whole MPS is going to need a heat shield at that point. But see, here's what I'm thinking, dudes. Why even note this in a report about Centaur? Well, okay. It was designed to put the EUS up there. The EUS has way more mass than a Centaur, right? But if you're going to standardize around Centaur, that leaves you with a lot of extra payload margin for what you're trying to do. That means that, you know, with Centaur, you're not going to be able to put as much as you could out to the moon, but you have that extra mass to play around with to put a heat shield on the MPS and get the stupid thing back. It does make sense. You're basically taking weight off the top of the rocket and putting it at the bottom, which, I mean, if that gets us some RS-25s back, I guess I can't complain about that. If they use the engines meant to be thrown away in the first place, we wouldn't need to consider smart reuse. Is an SLS too heavy? I just explained why that could be useful if you're standardizing around a Centaur, specifically mentioning like mass and weight of things. Like I just mentioned that. Remember the Blue Origin heat shield thing? Yeah, there you go. Hey, that's my idea. Yeah, there you go. If needed, could you put a couple of really small solids on the second stage to get Orion to low lunar? I mean, you'd have the payload margin to do it, X-Wing. I just don't know if they're all about that. We could bring the IUS back and use it as a kick stage for circularization. That would be kind of cool. I highly doubt they're going to do that, but that could be cool. Mars crewed missions. The SLS Centaur 5 combination will provide the heavy lifting required for future crewed missions to Mars. Yeah, no, it won't. You nerfed the upper stage. But, you know, whatever. A description of these missions and a pathway to Mars is given in detail in the author's paper entitled, What Does a Human Mars Campaign Look Like? Reference 5 published concurrently with this paper. Well, we're going to have to read about that. The Mars paper sets forth the rationale for the preliminary necessary steps that must be taken that would lead up to an eventual crewed mission to the surface in the early 2040s. The SLS is a key element to that buildup as missions are flown at each The SLS is a key element to that buildup as missions are flown at each Earth-Mars mission opportunity window. Proper alignment occurs only every 26 months, like we were saying. The various crewed Mars mission elements necessary for eventual crewed missions with durations of 2.9 years are indeed massive and thus require multiple heavy lift launches. The precursor missions set the stage for the later crewed missions by emplacing assets at validating technologies and operations at Mars, including but not limited to large inflatable aero brakes for the descent vehicle to the surface and in situ on the surface propellant production systems for fueling the crew's Mars ascent vehicle on the Mars ascent vehicle on the surface with liquid oxygen made from CO2 in Mars's atmosphere. Yeah, Sea Kraken. Yeah. Mm-hmm. The series of precursor missions carried out during the 2030s are necessary before a crew mission can be flown. These missions, the progression of capability and technology validation, and the role that the heavy lift SLS will play are outlined in that paper along with prospective schedules that lead up to a crew mission in 2043. Yeah, we're going to have to go check that paper out too. I'm interested to see how they want to do this. Mars Sample Return. Another potential mission taking advantage of the capabilities of SLS Centaur is the Mars Sample Return mission. SLS can inject 22.1 metric tons to Mars on an average year, C312. This large payload could be used to simplify Mars Sample Return by allowing the mission to be undertaken with a single launch vehicle. I agree with that. The all-in-one launch would inject a Mars Sample Return lander that carries a two-stage Mars Ascent vehicle. For this Mars Ascent Vehicle solution, the ascent stage would lift off the surface after sample collection and could accelerate the Earth return vehicle to trans-Earth injection, ERV and TEI, with a Mars departure energy of C3 10 kilometers squared per second squared. Complex operations include in-space transfer and rendezvous with and sample canister transfer to a separately launched, pre-emplaced Mars-Earth in-space transfer stage could be eliminated. I actually agree with this. Yeah, that's a good idea. Can we get Dragonfly back on the books? Dragonfly is back on the books. It's been back on the books. Only the SLS can inject a payload robust enough to allow this simplification. Mars ascent simulations show that the MAV can reach the required velocity if a space-storable two-stage liquid propellant system is selected. Oh, I mean on SLS. Oh, yeah. A solid propellant motor propulsion system would be inadequate for this approach due to its inherently low specific impulse. Okay, you could do a Europa lander, you could do a Uranus orbiter, interstellar explorer. Yeah, okay. So you have a lot of options here. I would like to point out, just as a matter of record, that you can literally do every single one of these things better with the EUS. Just putting it out there. You could do every single one of these better. These numbers would pretty much double. All your characteristic energy numbers would double with an EUS. But, like, I'm just putting it out there. Centaur will do it, though. SLS to Centaur adapter options. See, this is what I'm wondering. Two viable options exist for configuring SLS to Centaur 5 adapter. The purpose of the adapter is to support the mass of the Centaur and the payloads above it during core stage flight. Two options include a short conical adapter that goes from the 8.4 SLS core diameter forward skirt to the aft end of the 5.4 meter Centaur aft skirt. This option is illustrated in Figure 2. The solution keeps Centaur 5 in the load path of Orion or other payload, i.e., during core stage flight, Centaur is carrying the load of the payload, Orion, which is very heavy. For this solution, the SLS core stage will be limited to some reduced maximum acceleration limit. For the Block 1 ICPS configuration, that limit is 3.3 Gs. This limit is maintained by engine throttling. For the new Centaur 5 configuration, that limit will be reduced to some lower value. For this short adapter that keeps Centaur 5 in the load path, for purposes of estimating payload capability for this report, max acceleration was limited to 2.75 Gs in the ascent simulation. That's really low. Yeah. This lower acceleration level affects the flight of the core stage. With a lower max acceleration limit, the core stage ascent flight is slightly less effective and takes a little bit longer. This is partially balanced by the fact that this short conical adapter weighs less than the option 2 adapter. Preliminary estimates indicate this option 1 adapter weighs in the order of 4,000 pounds. About 2 metric tons. Actually, it's closer to like 1.8 or 1.9 metric tons. The second option involves a cylindrical adapter plus conic adapter on top. These two together form one adapter that entirely closes the Centaur 5 and directly supports the payload above. The bottom half of this adapter is 8.4, and the top half is a cone that transitions from 8.4 to 5.4. See, that's what I said that needs to be done right there. That's what you need to do. It'll say why. This is what I mean when I said you're not putting a Centaur on top of SLS. You've heard me say this before. This, where is it? Hold on. This is going to screw your payload capacity horribly. It's going to basically, not negate, but for the most part, like, really, you're losing a lot of delta V to gravity because you can't accelerate this because you'll crumple it like a soda can if you accelerate too quickly. This is the option I think is the better one. Now, this will make it so SLS can basically yeet this as high as possible. That's what this is going to say. I guarantee it. But it's going to take longer to manufacture. My argument was always that the time it takes to figure this out, you could have just made the EUS. But let's see what NASA says. Oh, thanks, Blaze. I have the second PDF. Thank you. This adapter is called the Suspended Centaur 5 Interstage. The conical section connects the top of the Centaur and is configured to carry all of the loads above Centaur 5. This approach is common in launch vehicles. The advantage of this option is that the loads induced by the heavy payloads under acceleration during core stage flight pass around and not through Centaur. There you go. With this approach, the SLS core stage flight does not have to be restricted to a lower max acceleration and can remain at 3.3 Gs. As with the Block 1 ICPS, I'll bet you it could probably be more than 3.3 with this type of adapter, depending on how beefy you make the adapter. But then again, you make the adapter beefier, it's going to be heavier, a higher mass. The benefit is a slightly more efficient ascent as well as a structural relief on Centaur 5. The disadvantage is the longer, fully enclosed adapter will weigh more than the shorter option 1 adapter. Both options are viable and under investigation. Why? Preliminary estimates indicate that this option 2 adapter weighs in the order of 15,000 pounds, which is... So this adapter would be 2 tons, and this one would be closer to 7. The separation concept of operations is given in Figure 5. Is it, though? Oh, that's Figure 4, okay. So 1 is the enclosed thing. 2... Why would you do this way? What's the maximum G load for human rating? 4.5. I mean, that's basically, guys, that, you know, they just need to do it S4B style. That's pretty much what this is. But it's interesting because the pedals move with the separation system. That's not how that really worked. This basically takes it so the Orion stage adapter and the Centaur forward skirt, which is required for this, you need to redesign the forward skirt on Centaur a little bit to be able to be load bearing, which is not that big of a deal. That's fairly easy analysis because Centaur already exists. It's harder to do that when you have a conceptual stage here. Aft OLP sep joint fires. PAS impulses. The payload attachment system impulses Centaur out of the inner stage. Lanyard pull initiates the forward OLP sep joint and the LEA thrust joints and jettison of fairing quads and dampers from the Centaur 5. Cutters free lanyards from the inner stage. I don't know why you do this way. Why not just make them... I mean, Saturn V did it, so... Saturn V pulled its inner stage with it and then separated it like that, so I suppose it's not the craziest idea. How much does an RL-10 weigh? Would it be enough to consider a single stick? Single stick? What? What do you mean? A single stick SLS? No, you don't want to do that. You don't want to do that. No, that's not. Yeah, you don't want to do that. Yeah, don't do that. Yeah, no, we don't want that. I don't think SLS has the TWR to even lift itself up. I don't think the core stage by itself fully fueled has 1.0 TWR. I'm pretty sure it doesn't, because it doesn't need to. Conclusions. Today, NASA's Moon to Mars Artemis program is heavily focused on producing accomplishments at the moon. The Artemis launcher, the SLS, will also play a key role in crewed exploration of Mars. Yeah, well, with this dinky upper stage attached to it. In parallel, a series of high science value, robust robotic exploration missions can be flown that will open up a window of scientific discovery. Several of these missions are only achievable with the flight-proven SLS and Centaur 5 elements. Each mission will maximize payload mass delivered, and thus scientific return, and or maximize the trip time by capitalizing on the capabilities of SLS. It has 0.8 TWR. Yeah, you'd need a 5th engine. I mean, this will work, but to be fair, what Seacracken Boy is saying isn't that crazy. It's because SLS itself has a lot of delta V and is very powerful. It basically gets the second stage to orbit full or almost full. So second stage TWR wouldn't be that much of an issue. But that maybe would be cutting it close. What? That's not what he's saying at all. Brother, if you don't have the SRBs and you launched a single stick SLS core stage with a Centaur and Orion on top, the Centaur you'd need to use the Centaur for circularization. You basically take any usefulness of having a third stage up there and throw it out the window. What are you talking about? That's not right at all. He's talking about a single RL-10, not two. You said single stick. That's not no. Single stick is not that. Single engine Centaur. Lava is correct. Man, all right. All right. Here, I'm just gonna say this. All right. If I misspeak, it's not a big deal. If you misspeak, we're both misspeaking, and that makes for a bad time. Okay. Just bear with me here. Why build an entire SLS cargo when there's Falcon Heavy expendable? Falcon Heavy expendable is not going to be able to move any useful heavy payloads into space, guys. The way to say this is that Falcon Heavy is not designed to move a heavier payload to space. It's designed to move a lighter payload further into space. Falcon Heavy on paper can put 70 tons into low Earth orbit, but if you really wanted to go and you wanted to put 70 tons up there, I don't think you're going to fit 70 tons of anything inside of a standardized Falcon 9 fairing, so you're going to need a bigger fairing, which supposedly they're working on. But two, your second stage loads are going to get to be a big pain in the butt. Falcon Heavy, because it's not utilized, it's not designed to put 70 tons in space. It's designed to just have probably an 8 to 10 ton geostationary satellite on top of it, right? That it can shoot out to geostationary orbit, right? The second stage is not, it's just a regular Falcon 9 second stage. It's not really designed to have a crazy amount of payload on top of it because it's a Falcon 9 second stage. Falcon 9 can do maybe 20 tons on top of it and call it a day. Falcon Heavy, I would assume, is probably something similar, but actually, it's probably a little bit less than Falcon 9 because you have 3 Falcon 9s pushing up on the upper stage instead of just one at certain phases of the mission. So long story short, if you wanted to make Falcon Heavy move payloads around like SLS could, and theoretically it could, you'd have to redesign its upper stage. You'd have to redesign the upper stage. It's the exact same problem that you're dealing with here. And that's why SpaceX never bothered. Because instead of redesigning Falcon Heavy upper stage, they just said build Starship instead. And that's what they're working on. Could a Falcon Heavy put an Orion up there? No. Orion would crush the upper stage. Well, Bill, okay, napkin math. This is just me pulling numbers out of my tail off the top of my head. My tail off the top of my head. Okay, too many statements. I'm just kind of thinking about it for like 2 seconds here, which brain has not been doing good today, but you get the idea. Maybe just Orion. Maybe Orion is 25. No. Orion's 25 tons, which the stage might be able to handle. But if you put the launch abort system up on top of that thing, You're looking at a total mass here of the service module Orion with its LAS on top of it, the launch abort system, LAS, with the LAS, 36 tons. No way. It'll crush the upper stage. I'm 100% sure of this. Either that or you're... So SLS, they're coping hard with this option. You're coping so freaking hard. That is, yes, this will work, but you are stunting the booster. You basically have to throttle everything down and incur a gigantic grav loss to make sure you don't crush the upper stage. It's cope, dude. That's cope. That, you know, all these numbers, all the numbers that they have for C3 get thrown out the window if you use option 1. This line moves down here somewhere. It shifts, the entire line shifts down because you have to throttle back and you have to incur a gigantic grav loss so you don't squish the upper stage. This option, well, higher mass makes it so SLS can, you can use more of the core stage's capability. I'll take the mass trade-off any day of the week. Is this channel for layman's or for engineers or for anyone? It's for anyone, Gain. You've come in and ask questions. I teach at all knowledge levels. Even if Falcon Heavy could take 60 tons of TWR, the upper stage would be a problem too. Yeah, yeah. Hey, Worst, what's going on? Yeah, this is... Yeah, it's interesting that NASA, well, at least NASA knows that they're running into some gigantic load problems with this. Don't understand. Don't worry. I don't understand 95% of what's being said, but he's good at explaining it. Thank you. I was just asking because Falcon Heavy sent Europa Clipper out there, although slower than SLS would be able to, and cheaper. It's not cheaper, Orange. It's cheaper for your launch cost, but look, I said this when Europa Clipper was first moved to from SLS to Falcon Heavy. Now, granted, I will say this, if Europa Clipper didn't launch on Falcon Heavy, it still wouldn't have launched. If we decided to launch Europa Clipper on SLS, first of all, you need an SLS to do that. The big problem with the Europa Clipper mission is that they forgot to procure a launch vehicle. They just said that they were going to launch it on SLS, and then they went to, the SLS people said, wait, you are? Wait, really? What do you mean? What do you mean you're going to launch it? We don't... When were you going to tell us this? So... that's how that went down. So they did move it to Falcon Heavy, and everybody touted Falcon Heavy as being cheaper. It's not. It's not cheaper. It's cheaper from a launch perspective, sure. But because you said it yourself, dude. Because Falcon Heavy is going to take probably triple, I think it's like triple the time to get Europa Clipper to Europa. Your mission operations and your life cycle of the entire mission just was tripled. Mission operations in typical systems, typical like spacecraft systems engineering, basically constitute over 50% of the total cost. My argument is that now keep in mind, the argument here is that if an SLS was ready, and it wasn't, so launching it on Falcon Heavy was the right idea. But to try and tout that as something that's going to be saving money is stupid, because it's not. Because you just tripled your mission. You just tripled your mission operation cycle. That's 3 times the amount of time that you have to keep the entire Europa Clipper team paid. Engineers aren't cheap. Neither are scientists. that total accrued time of the mission and the life cycle of the mission is going to exceed what the projected SLS launch cost would have been. And also, I really don't like saying that launching a science mission on this rocket is cheaper, because that's technically putting a price on scientific understanding. And I think scientific understanding is invaluable. Think about it. Now you're putting a price. You're putting a price on scientific discovery. I really don't think that that is a good idea. Because people that don't have NASA's best interest at heart can use that as a justification for cancellation. Not that they will with Europa Clipper, but with SLS, though. Everybody says SLS is too expensive, you know? Too expensive for what compared to the other moon rockets that we have? We've talked through this entire report here, right? We've talked through this entire report, you know, okay, well, what if we put it on Falcon Heavy? Okay, what if we didn't put, you know, what if we use the ICPS? What if we put the EUS up there? We don't have a rocket that can get people to the surface of the moon. Now, that could be possible in the future with Starship, and I hope that happens. That would be fantastic. But I don't hedge my bets on a promise. SpaceX's goals can change. It's very obvious. Their goals from 5 years ago are not the goals now. Right? 5 years ago, it was let's send stuff to Mars, right? Now it's build a AI data center on the moon. Priorities change. This is what I've been talking about for years, of subjecting your space program's stakeholder expectations to the whims of a capitalistic commercial space program. I don't think that's a smart decision. I really don't think so. I never thought it was a smart decision. I've been saying this for a decade. You go back and watch a space news from 10 years ago. I don't think I have any VODs from 10 years ago, but you got the idea. Yeah, this, not smart. Is that why the outer planet missions are harder to procure as far as interplanetary exploration compared to inner planets? Yeah, you need a big freaking rocket to get out there. The reality is that Musk lied. I don't... Baranok, I'm not sure what you mean by that. If you're trying to use this as some way to denigrate Elon, yeah, sure, of course, he has his flaws for sure. But that's not what I'm saying, dude. What I'm saying is that if we just done this in-house, at the very least, there would be government accountability. At the very least, there'd be government accountability, and we would be able to hold people responsible. You can't necessarily do that when you have commercial providers. What's NASA going to do? Throw Boeing under the bus because Starliner's a piece of junk? Now, to be very clear, Elon not keeping his promise, etc., etc., we'll see. Well, that remains to be seen. They need to deliver a lander by next year. See how that pans out. I think they'll do it. But also at the same time, you could have avoided this problem if you just built a lander yourself. That's always been what I'm saying. That's adding a step to an already complicated mission architecture. There are a complicated goal. You know what I mean? Oh, dude, I got into it with a viewer on Flame Trench a couple weeks ago. Guy was pissed. And he was like, why do you love SLS so much? I'm like, because it exists. That's a big reason. It exists. That's it. Is SLS the best architecture around? No, but it's good enough. You put an S, dude. If we could go to Douglas, which doesn't exist anymore. If we could go to Douglas and say build more S4Bs, and just put that on top of SLS, we wouldn't have any problems right now. EJSPCA is basically space news. You can order the video tab on YouTube by oldest first. Oh god, those are old meme videos that I did a long time ago. SLS exists and it does its job. You can't put a price on that. Yeah, which is why, Reaver, I always say it's really funny when people say it's too expensive. All right, compared to what? Starship? Compared to what? Falcon Heavy? That can't move stuff. That can't move people to the moon. Neither can Starship. Starship might be able to one day. Abso-freaking-lutely. You sure? It absolutely could, and it probably will, and it's probably going to be awesome when that happens. But look, man, here's the real, like, if we want to just reduce it to its base element, like, once again, I'm trying not to go on a rant here, but if you want to reduce it to its base element, look, I've been covering NASA and how they procure stuff and all, their systems engineering, the concepts of operations. I've been covering it for a very long time. Some of you here have been covering it for longer than I have. And you guys know good and well, every time we cancel something under the guise of a promise, it's not ended well. The space shuttle will get us back to the moon, so we don't need Apollo. Okay? In order for the space shuttle to move anything useful near the moon, we need to put a Centaur inside of it. Okay, cool. Let's design the Centaur. Okay, no, don't design the Centaur. It's too dangerous to put a hydrolox stage inside of a rocket that has a gigantic hydrolox tank next to it. Can't do that. Okay, so put an IUS in it. Put Titan's solid rocket upper stage inside of the shuttle and have that deliver stuff to space. Now, is that useful for delivering anything to the moon? No, it's not. It's useless for doing that. The IUS doesn't have enough delta V. So long shuttle lunar architecture. All right, so what are we going to do with the space shuttle? Okay, we'll use the space shuttle to build a space station. And then we can use that as a staging point for getting back to the moon. Okay, cool. Let's build a space station. Oh, look, the space station's too expensive. Work with the Russians and make a cut down version of that space station. Okay, will the space station have the servicing base so we can build stuff to get to the moon? No. It will not. That's too much, that's too expensive. Okay, so the shuttle just builds the space station. Okay, yep, get rid of it. We don't need it anymore. See what I mean? This has been happening for decades, man. Anybody that knows anything about NASA history knows that every time we cancel something under the guise of A, doing it for cheaper, and B, a promise that, what's even worse, a promise that it could be cheaper in the future, NASA ends up with less capability. And, like, I love Jared. Jared's doing just fine. Like, I understand he's making lemonade with lemons, but that is another one of those solutions. Now, I've talked to him. I've talked to him about this. He's a good dude. I've talked to him about it on Flame Trench. The idea here is that you lean into commercial. Commercial will supplement this compromise over compromise over compromise over compromise, right? Now, in the past, we haven't had such a healthy commercial spaceflight sector to be able to say that a promise is good enough from the commercial sector or not. Some people think that it is. Some people say get rid of SLS right now and just lean into Starship. I don't necessarily have a problem with that. I mean, they kind of are with the lander. But also at the same time, Starship to orbit is vaporware right now. Now, don't get me wrong. I know that's going to change in the future. I love Starship, and I would love to see it succeed, right? But the thing is that if we leaned fully into the commercial market at this point, right? If we leaned fully into it, there's no guarantees that Starship is going to succeed. If SLS had not a Centaur stage and on top of it and a bigger, like we kept going with the EUS, that at least gets you in the ballpark. That gets you close to the moon. It's a lot easier to develop one lander than develop an entire super heavy launch vehicle. Because the second somebody pulls the plug on SLS and cancels it, you're not making any more. Think about spaceflight projects like writing stuff on a blackboard, okay? You write stuff out on a blackboard, and then when you're done, you erase it. And once you erase it, it's gone. If you want to do the whole thing again, you have to write the whole thing out again. And that takes years to do. Decades. Hey, Stuart, $5. Thank you. Governments are also subject to the whims of political change, like changing presidential administrations and pork. So, Stuart, my thing is that everybody brings this up. Everybody brings that up. Oh, there's subject to change. And you are right. That's absolutely correct. Okay, the shuttle program then. Explain that one. The shuttle program went through 1, 2, 3, 4, 5, 6, 7 presidential administrations. 8 if you count Obama. Explain. SLS has spanned 4 already. Be quiet, Zilly. So, like, there's, you know, people say, like, oh, changing politics. Explain. Why does this exist then? Why did the shuttle program fly for 30 years, spanning from development all the way to the end of the program, spanning 7 presidential administrations? Because it's written into law. No, it wasn't, Lava Eagle. The SLS, canceling Constellation and the SLS program is what set the precedent of signing vehicle contracts into law. That's why canceling Constellation was a bad idea, because it made the precedent, the legal precedent, that Congress can denote NASA's architecture for space. Not NASA. How it was done before that is NASA designs something, the executive branch comes up with the stakeholder expectations, NASA designs vehicles for that, and then Congress funds the design, and then NASA farms it out to commercial to build the vehicles, and then NASA operates the vehicles. That's how the system worked basically throughout the first 50 years at NASA. It's time for docking coverage. That's correct. Yep. Tread carefully here? No, I won't tread carefully here. I don't like compromising spaceflight architecture. Any spaceflight architecture that's a compromise is going to compromise astronaut safety, and I'm not willing to shut up about that. I think that's a stupid idea. Nor do I want to put a price on science either. Saying that SLS is expensive is dumb because we don't have another lunar rocket. What are you comparing your price to? Saturn V? Comparatively, the SLS is way cheaper. Yeah, we're getting up to MS-29 docking. NASA needs to get back into the business of not having Congress design launch vehicles for them. And that might be what Jared Isaacman is up to here, which is good. And if Jared fixes that, well, look, I'll take this compromised SLS as if Jared reverses the precedent that Congress needs to design the rocket for them. NASA should be designing exactly what they need, and then they should go to commercial to see if they can make it. That's what NASA does. That's what they're good for. That's what you do. Bureaucracy compromises spaceflight architecture. Are you guys even listening to what I'm saying? The canceling Constellation basically made NASA a bureaucratic agency. That was the biggest problem with getting rid of Constellation. Hey Edmund, what's up, dude? 38-month resub. NASA exists the way it does because NASA money went back to the right congressional districts. It's a shame that is the way that's the funding work. That's not. I just said it, that's not what's going on. I just said that. Wait, what?
Discovery, go at throttle up.
Hey, Sydney, 9-month resub. But anyway, yeah, I'm going to go ahead and guess that they're probably going to go with this option here. The second option, despite the adapter being higher mass, will allow Centaur to be able to do higher energy insertions. These numbers here, these are notional numbers. I'll bet, despite the higher mass of adapter 2, having SLS be able to go full yeet during ascent will give you better throws or better characteristic energy. I say throws because you're throwing the payload to a planet or wherever. SLS is cheaper than the alternative. Anthony, there is no alternative. What alternative do we have? There's no alternative here. There's no other rocket that delivers things to the moon in one shot. Everything else is a refueling architecture, which is fine. I don't have a problem with that.
Oh, this is space.
Angry Medic gifted 10 subs. But yeah, we'll see. This is an interesting paper. There's still more to this. There's the other paper, what does a human Mars campaign look like? I'm actually interested in that one too. But we're going to pick up the docking coverage here. Security check required. I want to look at the pictures. I want to look at the pictures real quick. There's Lofted. That's the Lofted demo. Interesting. All right. Let's go check on the docking coverage here. This is the MS-29 docking here. Coverage should be starting pretty much now. I'm stuck on the idea of Jared reversing the trend of Congress choosing hardware. That seems to be the lowest and yet hardest fruit. Dude, he's already doing that. Like I said, Kerbal Guide, it's interesting because the Centaur 5 is a compromise for SLS, right? We've been talking about that. But Jared made that decision. That wasn't a congressional decision. Jared made that decision and Congress agreed with it. I'm just saying. That threw basically everybody's like, well, it's the bureaucracy. Well, no, it's not. You need a NASA administrator that knows what the hell they're doing. And they need to be backed by an executive branch with a clear and concise goal. That way, it's pretty obvious. Pretty obvious that that's the solution. And, you know, you could say, well, yeah, the bureaucracy, and yet something like this exists. You know, yet Centaur 5 and canceling ML2 and canceling the EUS exists, and Congress seems to be fine with it. Explain that one. It's not the bureaucracy. That's incorrect. I mean, yes, that exists, and yes, it is a pain in the butt. However, if Jared picks up the precedent that NASA needs to design the options, basically, NASA needs to design the vehicles and elements for whatever their presidential executive decree is for doing, like get back to the moon in 2028 and build a moon base. If we go back to the executive branch denoting what NASA should be doing, right? Congress doesn't seem to have an issue with it. That's all I'm saying. Yeah, if Jared can rectify this, I'll take SLS Centaur. That's fine. Because it sets up the precedent for NASA building the launch vehicle that they absolutely need in the future. Period. Full stop. Like, maybe they say, let's build another Saturn V or something. Probably unlikely. But yeah, it's interesting that that's the kind of conclusion that we came to here. That's a good idea. If Jared can fix that, I'll forgive him for canceling EUS and ML2. Because that, I mean, what SLS really needs is a high energy upper stage. Like, that's the big one here. SLS needs a Saturn V third stage on top of it. And Orion needs a higher Delta V service module. If we can go back to doing that, right? Then, oh, weird, dude. If we give SLS a stage that can move 45 metric tons TLI, translunar injection, so basically double the characteristic energy of what you guys just saw with the Centaur, that's the stage that NASA needs to be able to use their own rocket for single launch lunar exploration. And I think that's a good redundancy from a safety perspective to the fueling architectures that we have with Starship and with Blue Moon Mark II. Anyway, here's the Soyuz MS-29 docking coverage here. This is a shot from onboard the spacecraft.
In the lower left-hand corner of your screen, at the very bottom, you'll see two values. The 4.845 kilometers represents the distance between Soyuz and the station.
And that's your closing velocity.
And the value right below it is the rate of closure, currently 8.8 meters per second. Again, as we mentioned earlier, that distance will close, is continuing to close second by second. The rate of closure will continue to diminish, especially during the fly-around that will position the Soyuz for a precise alignment with its forward docking probe to the Prashal module docking port before the command is given for final approach. This entire operation is being conducted autonomously based on computer input on the onboard computers on the Soyuz MS-29. Seated in the descent module, the center section of the three-section Soyuz vehicle, the Soyuz commander in the center seat is Pyotr Dubrov. To his left is board engineer number 1, who is Anna Kikina of Roscosmos, and to Dubrov's right is NASA astronaut Anil Menon, serving as board engineer number 2.
And the current range is 4,010 meters, and range rate as 8.8. Copy.
We're about 13 minutes away from the initiation of the fly-around.
You're guessing C is the abbreviation for second. No, that's meters a second, dude. M is the same in Russian as it is in English, but C is an S, so that's meters a second. So Soyuz is closing, MS-29 is closing to the ISS. It's 3.7 kilometers away, closing at 8.86 meters a second. That means it's moving towards it at 8 meters a second, or closer to 9 meters a second, which is about 30 feet per second. Yeah, it'd be 30 feet per second, give or take. Up here where this is 3AXBAT, that's ZAHVAT, so Zavat, Zavat Kurs 1, which, see KYPC right there, that's KURS, Kurs, it's their, the automated docking system. So as long as you see Kurs 1 going on here, that means there's still an automatic control. If this switches off and you don't see anything right here, that means they've switched to manual control. Any news on the updated capsule? What updated capsule? What are you talking about, Chaz?
Operating in normal fashion. Once again, 8 minutes and 46 seconds after launch, at the point at which the Soyuz separated from the third or upper stage of the three-stage Soyuz 2.1A booster.
Oh, Geek, I misunderstood, man. Yeah, yes, meters a second. Yes, you were right.
Normally, and the chase began on this traditional, what has now become a traditional
Look, man, I'm not as sharp as I used to be because this year has repeatedly kicked me in the scrotum a couple of times. So, yeah, dude, like I'm not as sharp as I usually am.
Last several years,
You gotta give me cut old EJ some slack.
Space Station. In the old days, it used to be a 2-day rendezvous, and the
I think Dragon will retire before Soyuz.
To a 2-day rendezvous.
That'd be funny.
Should a technical issue require that to occur following launch, however, as has been the case.
Sorry, the new Soyuz
In the case
capsule.
of today's activities, the 2-orbit rendezvous was declared operational and in play.
The new Soyuz. Oh. The new Soyuz capsule, we've seen it do stuff like that, but I frankly have no idea if that's supposed to do that or not. At this point, the new Soyuz capsule is not Soyuz; it's called Oryol, which is the Russian word for eagle. I don't know what that capsule is doing. I don't know. I stopped kind of covering what was going on in the Russian space program for a little while.
The info panel. Copy. We are monitoring the KDU parameters.
Probably rates lava, but I'm taking a guess. I don't know for sure.
Combined GSO is confirmed of GSO 1, 2, 3, and 4. SKD thrust at 202649 is confirmed.
No, Maddie, they're loading payload in the vehicle right now.
The so-called Impulse 4 burn is underway using the main engine on the Soyuz. This is about a 16-second burn. We're about 2,000 meters away from the International Space Station at this point. Within the next couple of minutes, Flight Director Chris Dobbins here in Mission Control will poll his team of flight controllers for a go, no-go for docking. As you now have a better view at the top of your screen of the Prashal module to which the MS-29 will link up to in about 28.5 minutes. And of course, it is attached to the Naoka Multipurpose Laboratory module.
Naoka?
The International Space Station is currently
Isn't it
traveling
Nauka?
over Uruguay, about to move from southwest to northeast into southern Brazil.
We see it in the right window. And we see the ISS on
And
the
there's our first view of the Soyuz MS-29. A very good view of the thruster firings on these impulse burns, mid-course correction burns, to fine-tune the Soyuz's approach for its docking to the Prashal module.
With the
Ooh, Prashal. That's on the very, very bottom of the space station. Nauka. Yeah.
Range is 1,600. 4.2 is the range rate. So the course data is just as predicted.
Можно с КСП, ну либо с формата СССР. А можно с СССР.
And verify what you see on the display. You can use the AGC mode, working with the AGC mode, and we can leave it as is for now. So 4.1 is the range rate, 1.3 is the range.
This is a crew mission. Yep. There's we got 3 souls on board. There's the commander of the mission, which is Peter Dubrov, who's a cosmonaut from Roscosmos, and Anna Kikna, who is also from Roscosmos, and then we have NASA astronaut Anil Menon on his first flight into space here. And this is Soyuz MS-29. It launched pretty much 3 hours ago. Liftoff was on time at 10:47 a.m. Eastern time. And yeah, Soyuz uses a 3-hour docking window because it's tried and tested. It can get to the ISS very quickly. So you see MS-29 doing its fly-around maneuver to line up with the module that it's supposed to attach to here. The one it's supposed to attach to is the Prichal module, which is on the very bottom of the space station. Prichal is a multi-axis node that's attached to the Russian science module called Nauka. That's Nauka right there. Prichal's over there. We're actually upside down relative to station orientation here. So if this camera goes that way, you'll be able to see Prichal. What capsule holds the record for shortest time to the ISS? You're looking at it. Not this particular mission, but a Soyuz does. There were plans for a bigger Soyuz capsule called Zarya, which would have launched on Zenit. Yeah, that didn't happen. Why does Dragon take way longer to dock? Orbital mechanics, long story short, Cowick. Dragon could get to the space station this quickly. Yeah, it could, but they just choose not to. It's just easier with the Florida launch site to just use a 24-hour. The reason why is you're more likely to get launch windows that way. I mean, Dragon is... I'm not going to say Dragon is bigger than Soyuz, but Dragon is a little bit heavier because it carries its service module with it, and the service module is reusable. So, yeah. Or orbital mechanics really is your thing there. Okay. So, that right there, this ball right there, that's Prichal. It's a multi-axis docking node. They're aiming for the bottom of it.
80 as the range. Copy.
762
so
meters
far,
away.
all of the mid-course correction burns have been executed as
That's
planned
Prichal
per
up there
the
on the left.
timeline. No issues. Again, this view now from cameras on the International Space Station of the approaching Soyuz
No,
vehicle.
we're going to do it, Ari.
We're about 700 meters away.
Lava, something like that.
700 is the range. 245. 2.45 is the range rate.
2.45 representing the rate of closure between the Soyuz and the International Space Station. Again, at the time of contact and capture, at docking, less than 23 minutes from now, the Soyuz will be traveling at just 1/10 of a meter per second for its initial contact with the docking port. At that point, the relative motion of the two vehicles at the docking interface will be allowed to dampen out against one another before the forward docking
Yeah, there's a
probe
mystery goo
begins to
canister right
retract
there.
to bring the two docking interfaces flush against one another and initiate the closing of the hooks for a hard mate.
Everybody likes that.
100. 1.65 is the range rate.
Yeah, Ride Tech, this launched 3 hours ago.
Copy.
The International Space Station and the Soyuz flying over the northeast portion of Brazil, about to move across into the Atlantic Ocean.
So Soyuz is on a automatic docking system. Right here, you can see on their UI, it says Zavat Kurs right there, KURS. That's the autopilot. If you see that switch off, that means they've switched to manual control. Now, there's a couple of different options here. They can take manual control. Peter can take manual control of the vehicle. Peter's the commander. He can take manual control of the vehicle himself, or if for whatever reason he can't do it, they can control it with, they can use Soyuz remote control, and they can control it from the space station. depending on whatever scenario works. Depending on whatever they need. But yeah, right now she's on autopilot. This is course right there. They're 454 meters away. Close rate is 1.48 meters a second. Docking is scheduled to be in about 20 minutes.
140.
And as you watch this view from the external television camera with the engineering data overlaid from the Soyuz MS-29, we're inside a minute from the initiation of the fly-around by the Soyuz to precisely align itself with the Prishal module. And again, this view of the Soyuz as it and the International Space Station pass off the northeast coast of Brazil over the Atlantic Ocean. And fly-around has now been initiated.
390, 152.
This fly-around is at an angle of about 54.5 degrees. It will take just about 6 minutes to complete before the Soyuz puts the brakes on, comes to a halt on automated command to enable a few seconds worth of station keeping and one
What a
final
shot.
look by the flight controllers at the Russian Mission Control Center in Korolyov to ensure that they're happy with the alignment of the Soyuz to the Prishal module. At that point, the Soyuz will be at a range of almost 200 meters away.
With the fly-around velocity profile. I can see the station on the periscope, RS node, docking port.
Yeah, Paul, right?
Принято.
Copy.
All the time by him.
330,
Most people are kidding, though.
0.75 is the range rate.
Принято.
Copy.
What are those two pointing things on the sides? These are radio antennas. One of them is for communications and data, and the other one is the docking antenna. And then this little guy sticking out of the top is the periscope. Yes, you heard that right. Soyuz has a periscope. That's in case Peter needs to do a manual docking using Toru. He can basically look through the periscope. The reason why is because Soyuz is made up of 3 modules. You have your orbital module at the front, and then the descent module in the center, so the crew module, and then your service module at the back. Sergei Korolev designed it that way. I'm not exactly sure why, but he did. So there's no windows out the front. You have to look through. If you want to actually look out the front, you have to use the periscope.
For the Russian flight control team outside of Moscow.
280, 0.59
Yes, you can, Panta.
is the range rate.
Принято.
I meant the solar panels. Why do you need solar panels? Well, you need solar panels to generate electricity on the spacecraft. You could use a fuel cell or something, but that's extra mass. For the type of missions that Soyuz does, for the long-duration missions up at the ISS, solar panels will generate electrical power pretty much indefinitely. If you have to carry extra fuel, the spacecraft is heavier for like a fuel cell or extra batteries or whatever. Yeah, these are solar panels sticking out the sides.
25 degrees is the Palanque angle. 250 is the range. 0.4 is the range rate.
250 meters separating Soyuz from Prishal.
If you're talking about the pointy things that are coming off the end of the
Good,
solar panels
range
visual,
rate and,
I'm not
rate of
100%
closure.
sure. Those maybe are antennas for something. I don't know.
240 метров.
Be right back.
240 meters. 0.38 is the range rate. Copy.
Контролируйте К-15 загорание.
Unintelligible.
What is the theta and omega readings on the left side of the docking view?
Again, looking at the values
I have
on
to
the
look it
lower
up,
left-hand
Rarest. Give me
portion
1
of your
second.
screen, 230 meters separating the Soyuz from the Prashal module, closing at a rate of 0.25 meters per second.
We are in 15 degrees zone. K-15 is not lit. Copy. We have acquisition on course 1. 211 is the range for course hardware. I have approach on course 1.
And we have a report of a good lock-on between the Soyuz and the Corps' automated rendezvous system on the Russian segment of the station.
It's
K-15
YPR.
is not lit.
Okay. So the rates are over there, yeah? There we go. That's the docking port.
I have K-15 indicator lit. Copy.
Можем подсветку ВСК включить.
We have roll maneuver ongoing. Copy, will activate periscope backlighting. 2041 backlighting is on. Copy.
Так, ну и фару С-17.
And the headlamp C-17. Copy, we have a go to activate headlight S-17, commanding 2041 headlight is activated. Copy. Continuing the roll maneuver. 201 is the range.
200 meters
rate,
out.
0.12.
12 centimeters a second. Close rate.
We have station keeping at 2042.
Принято, есть завкон.
Copy. Station keeping.
Тигр,
198.
на выдачу причал. Формат
You have a
движения.
go to command approach. Copy. We have a go to command approach. 204240. I commanded approach.
Принято.
We have approach. Depot thruster firing.
Beautiful.
With fly-around having been completed, the Russian flight control team immediately happy with the angle and the location of the Soyuz relative to the Prashal module, so final approach is underway. Docking is scheduled about 13 minutes from now. Everything continuing to go very smoothly. It has been 2 hours, 55 minutes, 41 seconds since launch. And from the launch pad at Baikonur, the Soyuz is in the home stretch of its trip to the International Space Station, where Anil Menon of NASA and Roscosmos cosmonauts Pyotr Dubrov and Anna Kikina will spend the next 8 months.
We can't adjust it right now. Copy.
Beautiful.
Тигрицы, просьба ТВ больше выдать. Развернуть экран.
The Soyuz and the station, now approaching the west coast of Africa, will fly directly over the Western Sahara and Morocco, moving from southwest to northeast at an altitude of 260 statute miles.
77 is the range rate. Copy.
So this is a shot on the
130 meters, 0.70.
this is a shot on one of the cameras that's on the ESA's module. This is on the Columbus module. I know because this sensor that's behind me is on that module. So this is a camera that's up at the front of the station looking down. No, it can't be. It's going in the wrong direction. I'm not sure where that camera is.
110 meters, 0.57 is the range
Once
rate.
going
again,
the wrong
you're
way
looking
for that
right down the
camera, for that to
barrel
be
of
on
the
Columbus.
Prishal module.
I have
104
the
meters
target
separating
one
Soyuz and
lower
Prishal,
and
closing at a rate of
center.
0.5 meters per second.
Copy. 100 meters, 0.57 is the range rate.
17,500 miles an hour. EJ, does the Soyuz docking port require specific lineup rotation-wise? Yes. Soyuz uses an it's called the SSVP. It's a probe and drogue system.
90 meters. 0.45 is the range rate.
Soyuz is going to have a prong that sticks out the front that basically aligns in that this conic area right here, and yeah, it'll rotate to the right direction once it completes soft capture.
Copy.
Okay, so this refers to, this is the phase of the autopilot here.
Is the range, 0.36 is the range rate.
So docking right here. This is, Kurz is in docking mode now.
Target
Ooh.
is 1
No,
degree
oh, come back.
lower from the center.
Принято.
Copy. 70 meters. The docking port dimensions are in accordance with expectations.
метров.
65 meters to target.
Meters, 0.28
28
is the
centimeters a
range
second.
rate. Target
Close
is
rate.
near the center.
What a shot.
50 meters, 0.2 is the range rate. Angular dimensions of the docking port are in accordance with expectations.
The flight controllers in Korolyov very happy with the alignment of the Soyuz
You can
and
see
the Prishal
the
module.
probe right there on the front of the Soyuz
Soyuz and
docking
the
port.
International Space Station flying almost directly over Casablanca.
Docking system readiness, copy.
Maybe not today, maybe not tomorrow.
40 meters, 0.18 is the range rate. The target is 1 degree to the left from the periscope.
The reason the solar panels are pointed away from the sun. They're doing that whole docking thing right now. The Soyuz solar panels don't turn. They're
3 hours
fixed.
now into the flight of Soyuz.
35 meters, 0.13 is the range rate.
Just 35 meters away now from docking.
Принято.
There's the periscope. It's the green thing that's sticking out the top.
Angular dimension is 2 cells. That's for
You
the.
can see it says Prichal right here. That's the multi-axis node that they're docking to. That's what that says. It's still in the docking phase.
Copy.
So right here, it says SSVP right there. That
I have a little bit of misalignment in the roll
Hold
on
up.
the target cross. 0.13 is the
Ooh,
range
hold
rate.
up. Hold up.
Target cross. 0.13 is the range rate.
Does the capsule need to be power up when docked? It can plug into the space station's power systems.
25
But they
meters,
usually put the capsules kind of
0.13
in
is the
standby
range
mode.
rate.
You don't shut it off.
Copy.
Has there ever been a missed approach to the ISS, and what do they do if they misalign? So, all right, on that Soyuz, the screen from Soyuz, right, it says Kurs, right, and it says the phase that the Kurs is in. If the Kurs is doing something that they don't like, they can switch it to Toru mode. or Toru is manual control. Peter would take control of the vehicle and start looking through the periscope and manually fly it. Yeah, you'll know if they switch to Toru, that something has gone a little weird. If the docking camera stops saying KURS on it. Yeah, teleoperated mode. Toru would be station controlled. I think it would say, I have to look it up. It would say TKS, I think, if he was manually controlling it. Yeah, I have one of those hired. It's just, yeah, that's also Cygnus there. Yeah, it happens, Chris. Sometimes. Last time it happened was a couple of years ago. I'm switching to the other side of the screen.
We're just moments away from the docking of the Soyuz MS-29 to the Prishal module, everything continuing to go well with this automated approach of the Soyuz.
Does docking impart any force on the ISS? There's a spring built into the probe and drogue. Yes, it does, but the spring takes care of it. You'll see, Rarest, when it docks, the Soyuz will just start kind of doing this until they retract the drogue for hard capture. You'll see.
Target is in the center of the periscope.
That's correct, weather guy. Yeah. How long from docking? You don't want to put shock pressurization into the system, Sydney, so they're going to have to pressurize the area between the docking ports and then verify pressure equalization and go. It's going to take a second. It usually takes an hour. So. There we go.
8 meters.
8 meters out. So Rarest,
just
watch.
8 meters now separating Soyuz and Prishal.
Center, copy.
Perfect alignment reported by the flight controllers in Korolyov as we stand by for contact and capture of the International Space Station.
Kors is in docking mode here. It's picked up the SSVP alignment node, which is what you see right there.
Waiting for contact.
Stand by for soft capture.
Target is in the center.
Here we go, soft capture.
Contact confirmed.
We have contact, docking ring refresh.
Capture confirmed.
Copy.
See the whole stage move? The whole thing moves?
1:52 p.m.
See the camera moving, Rarest?
Soyuz has reached the International Space Station after a flight of 3 hours and 4 minutes in duration.
Let's switch to SSVP.
Docking occurring over the Mediterranean at an altitude of 260 statute miles.
SSVP is the name of the Soyuz probe and drogue. It means docking and internal transfer system.
Anya, let's monitor spherical tank pressure. Prop 507. Copy. Spherical tank 1. 151. Spherical tank 2. 181.
Now say it in
Once
Russian.
again, the Soyuz MS-29 has reached its port of call
Sistema
on the Prishal module on the earth-facing side of the Russian segment of the station. Contact and capture docking occurring at 12:52 p.m.
No, I don't
Central
think I
Time,
will.
1:52 p.m. Eastern Time. 3 hours.
Next, standing by.
3 hours and 4 minutes after its launch from the Baikonur Cosmodrome in
So if you
Kazakhstan.
squint your eyes, you see that they're
Forward
retracting the
docking
drogue,
probe, has
and
retracted,
Soyuz is
and hooks are
moving.
now driving.
Yep, they're moving it close.
The relative motion between the two vehicles dampening out. The hard mate will be initiated between the two vehicles at the docking
Soyuz
interface at the point.
It's
at
a little
which
crooked, and when they bring the drogue in, it'll
both
align.
sides of the docking interface.
See the top of the
That
ship?
will initiate
It's
a
moving
period
around.
of leak checks on both
See?
sides.
She's moving around just a little bit.
By,
That's okay.
cosmonauts Pyotr Dubrov and Anna Kikina.
It's not the record time regime,
Neil
but it's up
Menon,
there.
contributing his expertise to that procedure. And on the Soyuz side, Sergei Sverchkov, the station commander, along with Sergei Mikheyev, will be looking at their procedures as they initiate the leak checks on the station side of the docking interface that will lead to a hatch opening that is scheduled at around 3 p.m. Central Time, 4 p.m. Eastern Time.
Is the SR pressure, bowl pressure 800, instrument area pressure 884. Copy. Next measurement in 5 minutes. Copy.
Это ТВС, на инпут 2, можно выдать фотку ТВ.
You go to command TV system deactivation. Say again.
Input 2, откол ТВС, формата ТВС.
Yes, deactivate video system on.
This isn't me.
Copy. Deactivating.
That's not me.
TV system.
Так, 20:55:57, выдал ТВ откол.
Just got here. Why does Soyuz rendezvous so fast compared to Crew Dragon? Yeah, Orbits, that's a good question. It's the question I get asked the most whenever we watch the Soyuz dock. Soyuz is an older spacecraft. It's been flying for a long time. It's very well understood, so you can afford the quick docks. The other thing is just orbital mechanics. Soyuz is not it's a very light spacecraft, so you can use more of the rocket to get it there quicker. You know, you got to think of like something like Dragon. It usually takes 24 hours. It's because of orbital mechanics. And Dragon's a lot heavier than Soyuz, man. And Falcon needs some of that Delta V to bring that stage back. So, you know, all of that kind of adds up. Orbital mechanics, launch window, etc. All that kind of adds up, and it makes it so Dragon usually takes 24 hours. Now, could they do it? Could a Dragon get there in 3 to 4? Yeah, probably. Yeah, probably could do that. They just, it's no need to rush. But yeah, Soyuz has been flying for so long, and it's a relatively light spacecraft. They could just zip that thing up there real fast.
Once the Soyuz hooks are closed, that will trigger the closure of the hooks on the Prishal module side of the docking interface.
Moscow Station on Space Ground 1 for TV system deactivation.
So, Geek, fun fact, and I actually read what you said this time, and I read it again just to make sure. Fun fact, like, to launch the Soyuz, now keep in mind this is a customary thing. They turn the launch key. They don't show it. They never show that. But whenever they launch Soyuz's firing chain is armed by a freaking key, like GoldenEye style. You got to turn the keys at the same time. They do it because it's cool, right? Because it's old school. You know, it's just a customary thing. But yeah, that's how they start the auto sequencer on Soyuz. They have a freaking Cold War freaking console, and you put the keys in and you turn it. True story.
15 is
it is kind of badass. Like I gotta admit, that's actually pretty cool. It's ceremonial at best. Like they don't need to do that, but they do.
The entire rendezvous from launch at Baikonur to
this is Moscow Mission Control. These lines here are the range of the ground tracking stations throughout Russia. Yeah, that's their ground tracking range.
Pyotr Dubrov in the center seat of the.
Yeah, you can look it up. They do turn the key and they like push the button. It's pretty cool.
Anna Kikina, and to his right by NASA astronaut Neil Menon, contributed to the arrival at the
they have that too.
Station, and now soon will begin leak checks on their side of the docking interface, as will the cosmonauts on the space station side of the docking interface.
Yep.
Which will set the stage for the hatch opening and the greetings between the resident Expedition 74 crew and the new arrivals. Soon to have 10 people aboard the International Space Station for a period of 12 days.
Latches retracted indicator is lit. copy. That's G17.
So right here, what you're looking at is the automated sequence here. That says Programa Robot. That's the automated docking sequence. This is your mission timeline here. These are all the folks that are aboard the ISS right now, and what spacecraft they launched up on right there. This is the Expedition 74, so ISS 74 right there. Up here is all of the human-rated spacecraft or human exploration associated spacecraft that the Russians control. So these are all the modules that are on the ISS, and then MS-29, note, it's added inside of the brackets here. So Russian segment, International Space Station, Zarya, Zvezda, Poisk, Rasvet, Nauka, Prichal, Soyuz MS-28, Progress MS-33, Progress MS-34, and now Soyuz MS-29. Progress are unmanned Soyuz spacecrafts that are used for station resupply. So they have 4 spacecraft docked to the space station, docked to the Russian segment of the space station right now.
And now the SSVP mode is illuminated. I am sending D8 command.
I've seen this. Hired, yeah.
Power for SSVP is no longer illuminated. Probe retraction is no longer illuminated. SSVP mode is complete and is no longer illuminated.
This is Mission Control Houston.
And
The Soyuz MS-29 spacecraft is home at the International Space Station. All of the hooks are now closed on both sides of the docking interface. First, the Soyuz hooks closed following docking, which occurred at 12:52 p.m. Central Time, 1:52 p.m. Eastern Time, over the Mediterranean at an altitude of 260 statute miles. Once the Soyuz hooks were closed, the Prishal module hooks then closed, forming a hard mate between the 2 spacecraft. Now we'll begin a period of about an hour and a half or so for the leak checks at the docking interface by the Soyuz crew on their side and the space station crew on their side of the docking interface before the hatches are open.
The ISS crew is talking to the MS-29 crew. Come on.
we didn't even realize it. And there we are. And everything's nominal. Thank you so much.
That's Anna.
We even managed to drink some juice and eat the fruit bars.
Yes, fruit bars.
Baikonur, I read you loud and clear. This is Anil. Thank you so much to everyone who's been supporting us, who is making it all possible for us.
Congratulations, crew, on a impressive 3-hour rejoin. And to my friend Anil, how are you enjoying spaceflight?
Hello, it's great to hear from you, and incredibly fast ride. I'm feeling great, and I'm excited to speak with you. And
Hello? Well, I guess we're not supposed to hear that. No, Baxi, they've launched a bunch. They launched
We've
Progress.
had a brief loss of signal. What you heard were the Russian members of the...
Yes, we do, and we didn't hear anything before that.
Came in broken there, but I know you all have a lot of work to do right now, so just passing on to you.
ISS MCC Moscow and Space Ground 1 for Sergei.
Your friends here, your family, your nations are very proud of you. Godspeed and God bless on your expedition ahead.
Yeah, we can't do that, Ryan. It's not allowed.
Thank you very much for those kind words. The station is a sight to behold and a monument to all the hard work that we are able to do together and what we're able to achieve when we do it.
Yeah, dead bringer. There you go.
Петр Валерьевич, Анна Юрьевна, Анил, успехов, мы с вами.
Anna,
Держим за вас кулаки,
good
удачной
luck.
работы.
We're crossing our fingers for you guys.
Спасибо.
Thank you. Thank you.
Добрый вечер уже.
Greetings, guys. Good evening.
Всей команды, которая здесь.
Congratulations
It's Sergey Krikalev talking.
Переживала за
to you from our whole team
и желаем вам счастливого продолжения полета.
and wish you good luck and a great expedition. Baikonur, thank you so much.
Помехами, но нам очень
It's
приятно
a
получить
pleasure to
от
hear
вас такие теплые слова
words
поддержки.
of
Спасибо.
encouragement from you.
Sun's
Thank
going
you.
down.
Thank you.
Спасибо.
Штатная работа вам.
I'm just wishing you nominal up. Thank you.
You can see radiation has fried that camera. That's what all the
This
dots
is Mission
are.
Control Houston. What you heard over the past couple of minutes were congratulatory calls from members of the Russian State Commission, including the Roscosmos Director General Dmitry Bakhanov,
Oh, back
from
right.
a hotel in Baikonur where the launch occurred just over 3 hours ago, and congratulatory words to Anil Menon of NASA from NASA Administrator Jared Isaacman.
I thought that was
So the crew now will press ahead
Krikalev.
to
Oh, it was
conduct
Bakhanov.
leak
That's the
checks
guy
on
that
both
runs
sides of the docking
Roscosmos.
interface, on the Soyuz side and on the station side, before the opening of the hatch from the Soyuz, as well as from the Prashal module, to allow the new arrivals, Pyotr Dubrov, Anna Kikina, and Anil Menon, to float into the space station to begin their 8 months of occupancy. It was a flawless rendezvous and docking by the Soyuz MS-29, docking occurring at 12:52 p.m. Central Time, 1:52 p.m. Eastern Time. We will be back with hatch opening and welcoming remarks coverage on NASA Plus and YouTube and our other platforms, with coverage beginning at 2:30 p.m. Central, 3:30 p.m. Eastern Time. That'll be just about an hour and 23 minutes from now. For now, Soyuz safely home at the International Space Station. We'll see you soon for hatch opening and welcoming remarks coverage. This is Mission Control Houston.
Thanks, Rob. With Anil earning his astronaut wings, how many married couples does this now make that both have astronaut wings? I can count a couple. I know of at least 3. So Bob Benkin and I think Nicole Mann. No, not Nicole Mann. What the hell's her name? Megan MacArthur. That's it. And then I know that Hoot Gibson and Reese Eden were both astronauts and they're married. That's a little bit old school, but yeah, I can think of 3 off the top of my head. I'm pretty sure there's more. Do twins count as a couple? No. Hoot Gibson and Reese Eden. Yep. Mm-hmm. Yeah, Dan. Mm-hmm. Only Siamese. Okay, this is getting a little weird. It's getting a little weird. . So, yeah, you guys want to... We could do hatch opening here in a second. That's going to be in about an hour. Man, they're really making it kind of funky to... they're really making it funky to do some long format content because they space this stuff out just perfect. Jan Davis and Mark Lee, there you go. Oh, hold on. Northrop Grumman posted something. You guys want to see this? All right, so we'll do the hatch opening. Screw it. And then here. Northrop Grumman just posted this. You guys might like this. Uh-oh. What was that? That was some really, really short footage of the Pegasus launch that launched the boost mission. Bye-bye. That thing launched up into space, and that's the Swift boost mission. That right there is footage from the flight deck of the only airworthy Lockheed TriStar, the L1011. No, it's an L1011. Dude, it still has a flight engineer panel. Man, how many people know even how to use that thing? You've been flying the L1011 in Flight Simulator, and man, it's cool. I'm telling you, Lava Eagle, there's a reason why I like the TriStar over the DC-10 MD-11. I think the DC-10 MD-11 is a steaming pile of McDonnell Douglas. How about that? Meanwhile, the TriStar is goated. Was that its last mission? Yeah. Yep. It's a steaming pile of McDonnell Douglas. It's true.
Discovery, go at throttle up.
And see no engines flying off on the damn TriStar. I mean, it did have its problems, but I mean, tri-jets are just caca. The 747 ruins all of them, but whatever. Hey, Drunk Soul, 6 months. Opry and Titan, the family are doing well. Just started a new job. Just finished my new PC. This was dropped 2 hours ago. Man, this is going to be something demonic. Uh-oh. Oh, yeah. People have been linking me this the whole day. Somebody asked me if I'd seen it. If this was just posted, I'm not sure that I have. Oh, no. Uh-oh. Steaming pile of McDoo-doo Douglas. Uh-oh. Oh, that's bad. Oh, I'm sorry, dudes. I'm gonna play the frick out of this. Oh, that's the, that level's from BF3. Right, Tessa? It absolutely does. Clunk. Oh, no. Oh, no. Wait, was that backblast? Hold on.
Discovery, go at throttle up.
Yes. That will kill you. Equal and opposite reactions. Yeah. You shouldn't really stand behind someone when they fire an RPG or like a rocket launcher. Like, that'll kill you. Yeah. It's like if you stood next to, like, sideways next to somebody and they had a revolver and you were like right here. That would hurt. That would hurt a lot. No, this is Battlefield. It gets better. Oh, torpedo in the water! Oh, no. Meh. I feel the need. What's that doing there? I'm sorry? Did I... Freaking wake. Oh my goodness. Oh, that boat's gonna be freaking diabolical, dude. The one with the artillery on it. Oh no. Oh no. So that's a Super Hornet over there. And that looks like an F-14D, which... Huh. A two-seater F-14. Oh, I know. Hainan province? Yeah, I guess that's going to be near Hainan Resort. Yeah, that would be near the launch site. Yeah, that where China launches their Long March 5 and Long March 10. I yeah. I gotta sneeze again. Turbo. It's not space related, but I got video from the big boy. Oh, yeah. Trains. I like trains. You're dangerous. But you can be my wingman anytime. Nah, bull crap. You can be my wingman. It's interesting that that F-14 is not carrying any markings. There's no roundel. There's no... nothing back here. I mean, the V-stab should be painted black. I'm sorry. It's just, I don't make the rules, okay? Call it Changzhang. No. Why would I do that? Pax Armada probably gets the F-14. Well, at least put it in IRAF. IRAF livery, dude. The F-14s in IRAF livery look pretty good. I'm not gonna lie to you. Like, it looks pretty good. Too bad it's a steaming pile of F-14A. You know, that thing is kind of a piece of junk, but whatever. I mean, they don't exist anymore, but also. Yeah, give it the OPFOR camo. Yeah, I don't want it painted. I don't want it painted in the US Navy gray here, man. That's the Navy gray. No. Holy shnikes, it's a big map. Sura Reef. Yeah. Yeah, that's yeah, this is all coming. Dude, we're going to have to play more Battlefield. I don't understand, Meep, why it's a big deal saying Long March versus Changzheng. Operations are making a comeback like Operation Augur between Sura Reef and Wake. Oh boy. In a game mode called Hunt the Carrier. Uh-oh. That's pretty sick. I don't know why you'd sweep the wings to attack the ground, but yep, that's wake. Carrier's also there. 3 carriers are there? Hello? Question? There's 3 carriers in that picture. They all look like Nimitz. That one at the top might be a Ford class, but it's hard to say. Random idea, when you eventually decide to pick up MSC again, you turn off permadeath until you get back to the point where you died last time, then turn it back on. I'm not sure you can do that, X-Wing, but if I could, yeah, think about it. Interesting. It's dynamic weather. It's going to change during the match. Oh, geez. Oh, geez. Yeah, that's pretty... Dude, this thing, I can already tell you, is going to be diabolical. That thing's going to get annoying real fast. That's not gameplay footage. That's pre-rendered. There's no way that's gameplay footage. That's gameplay footage. Torpedo in the water! Jet wash? What jet wash? Just launch right behind him. Frick it. It's fine. Yeah, jet wash. Don't worry about that. That's the Sea Patchy. Yeah. Yeah, that, you know, just an Army helicopter taking off of a Navy carrier. The RCB-90 patrol boat. Cool. Just full send it, it'll be fine. Yeah, take off right behind somebody. Nothing bad will happen. Yeah. The contrail is going right into your canopy. I'm sure that's fine. Yeah, just do that. The war calls for whatever it takes. Army-Navy cooperation isn't entirely impossible. At Wake Island. Vash. Yeah, it's drafting. It's like NASCAR. Yeah. Someone can dream. It ain't me, but someone can. It's carrying a hull number 95. Right? Yeah, 95. Horsefly, I'm fairly confident if you tried to do a 80-degree bank turn at 180 knots right off the carrier, you'd probably find the ocean real fast. That's a real quick way to make an F-18 into a submarine. Like, I don't know, 180 knots might be fast enough. But you do have the gear down as well. Full burner, full flaps, 90-degree turn. You know what that F-18 would do? It would do this. It would go right into the water. You better have a handle on that ejector. Yeah, the ejector seat, exactly. You know, just give it more power. It's fine. Oh, yeah. Also, that F-18 is fully loaded. Now, like, I get it. It's Battlefield. It's just, it's funny to me, all right? Now, to be fair, planes, when you take off from a carrier, they do usually turn. But like that. Not like that. And this F-18 is not taking off with the catapult. The catapult starts right there, and there's the jet blast deflector right there. So this is a unassisted takeoff. How did this plane get to 130 knots? Buddy also rotated off the deck of the carrier. But who made this animation? All right, that's silly, even for Battlefield. That's just silly. Bro had all the lift. What? Who made this? Come on! Why? Why would you do this? Oh. Come on now. I mean, maybe they had a 78 knot headwind. You don't know. I mean, it looks pretty crappy out, so you might be right. Like, the tower is too far forward for a Ford class. Yeah, these got to be Nimitz, but it's carrying a hull number 95, and that can't be a Nimitz. What in the frick is an F-14? Why put it? Why? All right, never mind. Whatever. It's fine. Why are there Apaches at Wake Island? I hate it. I hate it a lot. That should be a Super Cobra. But that's an arm. You know what? It doesn't matter. It's Battlefield. It's fine. It's fine. It got blown away anyway. Marines make do. The Army would not trust the Marine Corps with its Apache helicopters. Heck, the Army doesn't even trust the Army with Apache helicopters. Where's the lie? Where's the lie? Boom. You saw what happened on the 4th. Where's the lie? What the Army doesn't know won't hurt them. $139 for backseater point of view. Oh, cool. It's just epic. What else do y'all need? Nothing. It's fine. It's Battlefield. I get it. Yeah. Hey, come on. No, Kim. No. How's the later Ford carrier doing the sea trials and things? I don't know. They played the Top Gun theme? Are you sure? Hold on. We can't listen to it. Can you just give me a second? Oh! Oh. Where are the MiG-28s? Well, it's funny you mentioned that, because this next shot I noticed something that seems to be a 5th-gen fighter on an aircraft carrier. Note how I don't look at the thing that this upgrade now, 5 instant unlocks. I don't give a frick about that. There's an Su-57 on an aircraft carrier behind them with the fuel hose unplugged just on the floor. Whatever, it's fine. Get the grapes. That looks like a highway. Oh. Is that any better? I mean, that's not a carrier. That's not a carrier airplane. Blind Ace weapon package with the RPK. Yeah, people that are blind use the RPK. That's right. It's a pile of junk, Boxy. It's the easiest gun to use in the game. Do you guys just, can I just... Just... I'm in my happy place right now. Yeah, I'm in my happy place. That's fine. I'll take my blind butt RPK and I'll do the Lord's work elsewhere. Drunksall, I will see you next Tuesday. No, season 4 comes out then, yeah. Yeah, it's got the arrestor hook. Horsefly, yep. I mean, it's definitely Super Hornet. That's Super Hornet all day. It looks comically large. It is a little big, isn't it? Yeah. I love Top Gun Maiden. I love that movie. That's like easily in my like top 10 all-time movies. And actually, to be honest, Maverick was better. That's one of the few times the sequel was better than the original. The sequel was fantastic. I love that, but that's like such a good freaking movie, dude. Like, Oh, man. You need to watch Maverick. You do need to watch Maverick. Maverick's amazing, dude. It's an awesome, awesome, awesome movie. I hate to admit this, but you finally saw Top Gun 2. It was freaking amazing. Dude, it's so good. For real, Horsefly. For real, man. Yeah. You told me not to think. So good. All right. I really want to watch it in IMAX. I only saw it in normal cinema. I watched Maverick in IMAX, dude. It was... I want to fly now, damn it. Maybe that's what we'll do today. I don't know. I'd have to get the setup out and stuff, but sorry, I'm still just staring into the trap, Ray. I'm sorry, like just that's not gameplay footage, guys. It's pre-rendered, but whatever, dude. It's a sweet reference. So that's a Super Hornet right there. Look at what the Pax carrier is. I would assume it's probably a Liaoning or something. Or at least I think that's the name of it. Yeah, Orange, it's amazing, dude. I don't think that's the Kuznetsov. So it's not the Kuznetsov. It's got a ski ramp though. Okay. So you guys are talking about this. It's not that. It's not right. The conning tower isn't right. That's got a... Yeah, see, it's Chinese. See the superstructure? Totally different on the Kuznetsov. Also, the Kuznetsov is kind of a pile of junk. Now, all right, little bit about naval history while we're on the subject. The Kuznetsov had a sister ship, right? So the Kuznetsov was just the first ship of its class when the Soviet Union collapsed, right? It had a sister ship called Voyag. Hold on. And then from there, so the sister ship was bought by China and they wanted to make it a museum or whatever, or a casino. And then they just reverse engineered it. They reverse engineered it and made Liaoning. Yeah, Liaoning is that ship. They basically reverse engineered the whole thing, took it apart, put it back together, and made a carrier with it. That ship was built in the Soviet Union. And then the Type 2 is basically kitted out like version of that. But even then, the superstructure isn't right for whatever the heck that thing is. I don't know what that thing is. It's got a ski ramp, but it's got a superstructure that looks like a Nimitz, and it's carrying F-15s? Question? No, there's an F-14 right there. But the Chinese do have another carrier after that. After Liaoning, they are building, the Type 3. The Fujian. But the Type 3 doesn't have a ski ramp. It doesn't have a ski ramp because it uses emails. It uses electromagnetic catapults just like the Ford does. But even then, that's like the Fujian is like halfway between a Nimitz and halfway between a Kuznetsov, or a Ford, I should say. Now, it could be the Vikrant. Yeah, that's a good point. There are other ski-ramped carriers around. This is the Indian ship Vikrant, but the superstructure doesn't match again. But it could be the Vikramaditya. But then again, the superstructure doesn't match again either. That was a Soviet helicopter carrier, and they converted it to fixed-wing operations. The Russians converted it to fixed-wing operations and then sold it to India. It was Kiev class, which was half helicopter carrier, half missile cruiser. This goes back to Soviet naval doctrine at the time. The Soviets didn't really see the need to have big power projection with surface vessels. Their entire naval setup was designed around supporting larger submarine architectures like the Typhoon class. So any surface vessels that they did have were just helicopter support carriers to support the submarine fleet with some surface level combatancy. So like a turret and a couple missiles, etc., etc. But the whole Soviet naval doctrine was designed to support submarines. So that's why they never really had a big, gigantic carrier until they decided they didn't want to do that and then made a fixed-wing aircraft carrier. And that's what the Kuznetsov is. So they figured out that having carriers is good for power projection, but then they realized, while building it, that they didn't have really enough money to do anything, and then the Soviet Union collapsed. Yeah, there were two Kuznetsovs being made. They were actually made in Ukraine. They're what the frick? What shipyard is it? Shipyard 444. Yeah, it's that's in Ukraine. It's Nikolaev. That's what it is. I forgot the name. Yeah, see. Used to be a big old shipyard. I mean, they still make stuff there, but they don't make carriers there much anymore. Now, the interesting thing is that the Soviet Union was calling for a bigger carrier. Yeah, the Ulyanovsk, which was going to be a follow-up to it, which was going to be a big super carrier here. They ended up never making it. What are we talking about again? We're talking about this picture from the Battlefield trailer. Well, what we're doing is we're waiting for NASA to pick up the coverage for docking ceremonies for MS-29. So we're just kind of passing some time watching the Season 4 trailer. That's not an aircraft carrier. That's I don't know what the hell that thing is. It's got a ski ramp. It looks like half Nimitz, half Kuznetsov. It's not really anything. And it has that looks like an F15 over there and two F14s. I don't really understand what's going on in that picture, but we've been comparing and contrasting it to every known gigantic aircraft carrier, and it doesn't look like anything. I don't think it's the Queen Elizabeth's, Martin. Unlikely. What submarine is behind it? Delta. That's a Delta 3 submarine, pretty sure. It would be a Soviet. That thing. Delta 3s are very, very big, very easy giveaway because they have the missile battery sitting behind the conning tower, and it's this big hump on the back. Also, that render is not real, by the way. The carrier that I played on it is the Indian carrier with a Midway class conning tower. Gross. Also, Baron, did you see this part? I like the reference. That's pretty good. EJ Space and Ship Review. That's right. Anyway, cool little trailer. I thought I'd seen that, but then they posted that like today, so it was clearly a new one. When is NASA going to pick up the coverage? No, we still got a little bit of time. The Top Gun game mode? Oh, wait, you shouldn't have said that. Interesting. I feel the need for speed. All right, Chris, heading out to watch football. The football, see you later. The foosball? Oh, France and Spain. Oh, France and Spain are today. I kind of want to watch that too. The hatch opening is going to be during the damn game. I think what I might do is, guys, okay, so here's what's up. Like, once again, the schedule's always in flux. You know this. So here's what we'll do. I will go watch the match, and the reason why is because I have to take a break at some time today. Bree is not working remote today. She had to go into the office. The office is in Boston. So that means nobody's checked on Titan since I've been here for a couple of hours. So, I think on the other side of the foosball match, I think we'll come back and, yeah. We've already done space news basically since 10 this morning, right? So I think we'll come back and play some games a little later tonight. I don't know. I'll figure out what we want to play. So, yeah, I said we would do some after hours tonight. So, you know, if there's any new particular space news around, we can Give me 1 second. Yeah, we could do that, but I think we'll, on the other side of the match, we'll just play video games. No NSF launch hype streams yet. They're doing countdown to launch, man. Then tomorrow is England versus Argentina. I'm sure, Chris, I'm sure England versus Argentina will be a perfectly civil matchup. I'm sure everything will go just fine. I'm sure that that will be a civil engagement where everyone is going to be perfectly nice to each other. You watch some Factorio later? All right, we'll come back and play Factorio. That's a good idea, Zelancho. I like that. No, yeah, no controversies at all. I'm sure that is, yeah, it's fine. Anyway. Anyway, so I will see you guys back here for Factorio a little bit later in the day. I got to take a break anyway because I got to go tend to the doggo. We have to, I'm not going to say it in case you're watching with pets. WALK, the DOG, to make sure he POOPS and PEEs. You know what I'm talking about? Anyway. Winner gets the Falkland. Yeah, maybe. I don't know. TREAT. Yeah, something like that. And Titan, what's his name? All right, guys. So I'll be back for Factorio a little bit later tonight, and then we'll probably play some Battlefield for after hours. So I'll see you guys in a little bit. Thank you very much for watching. And yeah, we'll be back in a little. We'll be back soon. I was about to say in a little bit. I just said a little bit, but yeah, we'll be back. I'll see you in a little bit.